Hi, I hope you're doing well today. This is your favorite math tutor, Dwight Dunn. Today we're going to be looking at two examples of trig graph applications. And trig graph applications going to be something that is very useful, especially if you're doing pre-calculus or math 3 or algebra 2. So let's jump into these problems. Now, the first thing we want to be very clear of is the keywords. The keywords for trig graph applications here going to be amplitude, period, midline, and frequency. So we have to be very careful in terms of how these things are calculated. Now, one other important thing that we want to be keen of is that most trig graph application problems we can always use a sine graph or a cosine graph to model these sinusoidal activity. So let's jump into the first problem right here that we need to be very keen of. So the first problem right here, if I can zoom up a bit, here we're going to be looking at on a typical day at an ocean port, the water has a maximum depth of 20 meters at 8 a.m. The maximum depth of 20 meters occurs 6.2 hours later. Assume that the relationship between the depth of the water and the time is sinusoidal. Write the equation for the depth of the water at any time t for t hours. So we're going to try to do two things. We're going to try to write this problem. We're going to use the sine graph to write this problem, to try to create a sine graph to model this problem, and we're going to use a cosine graph as well to model this problem. So let's jump into this problem. So the first thing is, let's do a quick sketch of what the graph would look like. So we know at 8 a.m., so we're going to put 8 there. The graph going to be at the maximum, at the higher, which is going to be at 20. And then we're going to be at 12 meters after 6.2 hours. So 6.2 plus 8 right here, it's going to be 6.2. Going to bring me at 14.2. Then 6.2 plus 14.2 going to bring me at 20.4. So that's going to be 20.4, right? Given the division, because it's 6.2 hours later, I know then that it's going to be at a minimum of, or the maximum depth of 20 meters. So starting at 8 a.m., I'm starting right here. I'm going to come down to 12 meters at 14.2 hours. And then the graph going to repeat. This is happening because the graph is a trig graph, and the trig graph pretty much have a symmetric property. So it is symmetric about from the maximum to the min. You can actually draw a vertical line that will cut the graph in two equal halves. Now we're going to need to identify the key terms in this. Firstly, we need the midline. The midline we know going to be the max, which in this case is going to be 20, plus the min, which is going to be 12, divided by 2. And then that's 20 plus 12 divided by 2. That's going to give me 16. So if I do my little rough sketch, let me use a different color. Let me use blue. Do my little rough sketch coming right across. Right? This here is my midline. That's going to be at 60. 16, not 60, 16. So that's going to be my midline. I need to figure out now my amplitude. My amplitude, if I remember, going to be the difference between the max and the midline, or the distance from the max to the midline. And that's obviously going to be 20 minus 16, which is going to be equal to 4. So that's going to be my amplitude. Now I need the period. The period going to simply be where the graph is repeating. If I look at this graph carefully, I realize the graph going to be repeating its pattern after 12.4 hours. So we start at 8, going to 6.2 to the bottom, and then for 6.2 more hours right here, the graph going to be going back up to the original 20 meters. So it's having that pattern. So my period then going to be the distance covered right here, which going to simply be 12.4. So my period going to be 12.4. Now I need to figure out what's the frequency. To figure out what's the frequency, I realize that the 12.4 is the period. So the frequency going to be 2 pi divided by 12.4. Now, most people would be a little bit confused. Why is it 2 pi divided by 12.4? Remember, the formula for the period is 2 pi divided by b, where b is the frequency. That would be equal to 12.4. If I switch the position of my b and my 12.4, I'm going to get the frequency to be 2 pi divided by 12.4. Now, we are in a position now to write the equation for this trig graph. Now, what I want to be very careful about is that we need to remember what the sine and the cosine graph looks like. So let's do a quick recall. And if I do a quick recall, I remember that the sine graph starts at 0, goes up, comes down, and looks something like that. Not drawn the scale, but you get the gist. The important thing here is that at the midline, it starts at exactly on the midline, goes up, then go and continue. So this is the sine graph. So the cosine graph, on the other hand, we need to remember that the cosine graph start above the midline, comes down, come back up.
That's what I do. Whoa.
Up, and this here going to be my midline. So we'll look at this graph carefully. To look at this graph carefully, the midline at 16, the graph is starting above the midline. So it's starting above the midline, and once it starts above the midline, it goes down and continue. Now I can start right here for my original graph, and I'm going to use the cos graph to represent this initially. So to use a cos graph, I realize for here I have a horizontal translation of 8 units. So because I have a horizontal translation of 8 units, I'm going to have y equal to, but we need the amplitude first. So let me look at the amplitude. The amplitude is going to be 4. Then I'm going to use cos. Now I know the period was 12.4, so my frequency is 2 pi divided by 12.4. Now once I have 2 pi divided by 12.4, I need a horizontal translation. Since the horizontal translation there going to be to the right, I am going to have x minus 8, because I'm going to the right, plus my midline, which is 16. So that's going to be my cos representation of the graph. Now I can also use the sine graph to represent this function as well. So if I use a sine graph to represent this function, let me just erase this for a second. I realize if I'm starting at the midline, this is going to be the midline right here. This is where the graph starts. Now, I know the sine graph always goes up, but in this case, it's going down. To simply use or represent where it's going down instead of going up, we're going to use a reflection. So to do a reflection over the x-axis, all I simply need to do, if it's going down, I use a negative instead. So I'm going to have y equal to negative, the amplitude remain the same, -4 sine, the period and the frequency remain the same. So that's going to be 2 pi over 12.4 x. Now this is where it gets tricky. Notice now for the sine graph, it must be directly on the x-axis. But in this case, it's going down. So directly on the x-axis is coincided with my midline. So it's also going to be the midpoint of this right here. So to find the midpoint of 8, between 8 and 4.2, I'm going to add 8 plus 8 plus 14.2. I'm going to add 8 plus 14.2 and divide that by 2, and that will give me the value here to be 11.1, and that would be the midpoint between 8 and 14.2. So my midpoint then is going to be minus 11.1. Let me go back up. And my midpoint here going to be 16. So as an experiment now, your task would be to write these two equations into your calculator, or you can use Desmos and then figure out if these two equations are the same. So I want you to take a shot at this, try this, and let me see what you come up with. And you can always share this in the comment sections in my video.